Origin and dispersal of agriculture.
Agriculture was not a dramatic overnight explosion that appeared all at once, fully fledged in one place. It took place over several hundred years against a background of ecological and environmental changes and social innovations. Understanding how agriculture evolved in the Near East and how it spread into neighboring areas or was adopted independently has been one of the enduring investigations of archaeology in the Near East and nearby areas. This objective is to provide an introduction to the origins, development and spread of agriculture with a view to providing a foundation for understanding the evolution of the world after the Neolithic, a world which saw the establishment of civilization. Agricultural origins cannot at present be conclusively proven to have begun close to 10,000 years ago, when additional evidence for agriculture extends further back in prehistory. What can be unequivocally stated is that agriculture had already emerged several times in numerous parts of the world in the last 12,000 to 20,000 years and possibly as early as 50,000 years ago, with the last 6,000 years producing the most evidence for this cultural phenomenon. Let us explore the evolution of agriculture and how it spread across the globe from the following topics.
The origin of agriculture, understanding dispersal, nature, mechanisms and speed of dispersal, dispersal of agriculture out of Asia, origin and dispersal of Indian agriculture. The origin of agriculture. Agriculture was developed at least 10,000 years ago, and it has undergone significant developments since the time of the earliest cultivation. Independent development of agriculture occurred in northern and southern China, Africa's Sahel, New Guinea, and several regions of the Americas. Agricultural practices such as irrigation, crop rotation, fertilizers, and pesticides were developed long ago but have made great strides in the past century. The Haber-Bosch method for synthesizing ammonium nitrate represented a major breakthrough and allowed crop yields to overcome previous constraints. In the past century, agriculture has been characterized by an enhanced productivity, the substitution of labor for synthetic fertilizers and pesticides, selective breeding, mechanization, water pollution, and farm subsidies. In recent years, there has been a backlash against the external environmental effects of conventional agriculture, resulting in the organic movement. Identifying the exact origin of agriculture remains problematic because the transition from hunter-gatherer societies began thousands of years before the invention of writing. Nonetheless, archaeobotanists, paleoethnobotanists have traced the selection and cultivation of specific food plant characteristics such as a semi-tough rachis and larger seeds to just after the Younger Dryas, about 9500 BC, in the early Holocene in the Levant region of the Fertile Crescent. There is earlier evidence for use of wild cereals, anthropological and archaeological evidence from sites across Southwest Asia and North Africa indicate use of wild grain, example from the Sa 20,000 BC site of Ohalo in Israel, many Natufian sites in the Levant, and from sites along the Nile in the 10th millennium BC. There is even evidence of plant cultivation and trait selection. Grains of rye with domestic traits have been recovered from Epi-Paleolithic 10,000 plus BC, contexts at Abu Huraira in Syria, but this appears to be a localized phenomenon resulting from cultivation of stands of wild rye rather than a definitive step towards domestication. It isn't until after 9500 BC that the 8 so-called founder crops of agriculture appear. First emmer and corn wheat, then hulled barley, peas, lentils, bitter vetch, chickpeas and flax. These 8 crops occur more or less simultaneously on PPNB sites in the Levant, although the consensus is that wheat was the first to be sown and harvested on a significant scale. There was a gradual transition from hunter-gatherer to agricultural economies after a lengthy period during which some crops were deliberately planted and other foods were gathered in the wild. Although localized climate change is a favored explanation for the origins of agriculture in the Levant, the fact that farming was invented at least 3 times elsewhere and possibly more suggests that social reasons may have been instrumental. When major climate change took place after the last ice age, c. 11,000 BC, much of the earth became subject to long dry seasons. These conditions favored annual plants which die off in the long dry season, leaving a dormant seed or tuber. These plants tended to put more energy into producing seeds than into woody growth. An abundance of readily storable wild grains and pulses enabled hunter-gatherers in some areas to form the first settled villages at this time. The significance of agriculture cannot be elucidated in terms of its origins alone, but involves a more detailed understanding of the emergent structure of its continuing spread. Understanding dispersal. The adoption of agriculture took place independently in a number of different geographical regions and environmental zones around the world, all at much the same time, but it is clear that the process that drove and characterized these changes and their spread from the core areas where they were first innovated were different in each of these areas. There are a number of ways of trying to track the dispersal of agriculture in geographical, social, and interactive terms. The archaeological record. Establishing a balance between these perspectives is necessary to get a clear picture of what happened. The presence of desert on the east and the Mediterranean on the west helps to concentrate populations within the Levantine area, preventing straightforward expansion and forcing dispersal channels. Genetics, or human and plant populations. Genetic studies can be used in 2 ways in this context. Extrapolating backwards from the modern genetic data, or to use ancient genetic data to attempt to make contemporary comparisons with a view to understanding population spread. Comparative linguistics. Explanations for language ancestry may give indications about shared language origins. Some linguists believe that recognizable traits of an evolved language can only be traced back as far as between 10,000 and 7,000 years, and that beyond this time, language would not be identifiable as a member of an ancestral group. If a language type appears hundreds or thousands of miles from its source, it is necessary to find a mechanism to account for it. This may include only few processes: language mixing, population mixing, via settlement, major presence, via trade, minor presence. Once agriculture was established in the Near East, it dispersed into Europe, towards Southeast Asia, and into Northern Africa by any one or a combination of a number of possible mechanisms. The grasslands and the forests of temperate Europe and Eurasia contrast sharply witnessed the steppes and the arid plains of the Fertile Crescent, and the spread of agriculture northward and eastward required new strains of plants and animals and different social and technological adaptation. Environmentally favorable situation for animals to be successfully adapted. Knowledge and experience of plant cultivation activities and animal husbandry and maintenance. Culture disposition. If the physical dispersal model is favored, then following needs to be applied. Increased population, sufficient plant fauna to enable surplus to be released, social acceptance, inability to challenge. If the idea's dispersal model is favored, the following also need to apply. Communications between different subsistence groups, some degree of synergy and agreement involving knowledge and communication between groups. Nature, mechanisms, and speed of dispersal. Dispersals from Southwest Asia went in three directions: Europe, Southeast Asia, and Northern Africa. They were not the only unique inventions of agriculture to be dispersed by different mechanisms, but they are the only ones examined here. In each case, dispersals may have been physical, that is by migration, conceptual, that is ideas and technologies being adopted by indigenous groups, or admixture, that is a combination of both. They took place in different geomorphologies and climatic conditions. The reasons for dispersal, whether by physical movement or indigenous adoption, could have been many and varied, but suggested reasons are for the adoption of pristine agriculture. Over the period of only a few thousand years, farming reached far west to Britain, far east to Southeast Asia, and far south to Egypt. Beyond the Levantine domestic package was not ecologically suitable. The establishment of agriculture outside its original area of establishment is usually referred to as secondary establishment, or as opposed to pristine or primary establishment in the Levant. The spread of agriculture in the Near East, that between hunter-gatherer and agricultural communities, differing mechanisms of physical migration of agriculturalists into new areas, cultural and consumptual adoption by local population, and interaction between different populations are all factors that need to be considered. How agriculture spread is how agricultural communities impacted the landscape and the much wider territories of hunter-gatherer communities. The sedentism of one group could impact a neighbor's activities. Similarly, the nature of existing hunter-gatherer communities would impact the possibility of change of use of territories and the likelihood of adoption of new methods by the indigenous communities. Hunter-gatherer societies did not adopt farming indiscriminately but selectively to fit the local needs. These needs varied from region to region, and so did the factors which combined to bring about the shift to food production. It follows, therefore, that there is no single cause for the transition which would fit all situations. Zweible, 1986, describes three main paradigms for the transition to agriculture by hunter-gatherer populations who are exposed to it: diffusion by colonization and or adoption, population resource imbalance, social competition. Rindos, 1984, believes that changes to plant morphologies and behaviors were caused by human alterations to their environments, and that human exploitation of plants within these environments caused these changes to be enhanced over the centuries. He offers yet another view of the way in which agriculture disperses, but with an emphasis on indigenous adoption rather than colonization. First, Early Holocene conditions favored plant growth. Grasses become increasingly abundant, including wild bean corn and barley. Locally, dense stands appear. Harvest periods are short and unpredictable. Second, trees colonized areas previously occupied by grasses, leading to a concentration of grasses at their margins. Grasses were then worth maintaining as a seasonally important food source. Third, establishment of permanent agricultural settlements were enabled by the arrival of grasses with domesticated features. The more labor-intensive character of the new cereals meant that land had to be prepared and maintained, leading to permanent settlement. Settlement locations had to be determined partially by the type of soils, light enough to till and organic enough to feed crops. Dispersal of agriculture out of Asia. Around 10,000 years ago, on the Fertile Crescent, the foothill regions of modern Iran and Iraq, as well as Syria and the Levant, the shift from hunting and gathering to agricultural production marked a key moment in human history. Prehistoric archaeologists have long recognized the importance of this transition and its subsequent spread in Europe and have sought to understand the process involved. The actual product of agriculture indicates that cereal cultivation spread rapidly along the Mediterranean coast to Italy and into Iberia and was certainly established by about 7,750 BP or before present. But these cereal grains show that the much debated spread inland occurred in fits and starts. It seems agriculture arrived in the Balkans around 7,950 BP, then halted for approximately 800 years before spreading rapidly to the northwest Europe, arriving with near synchronous dates in the Czech Republic and the Netherlands. The shift from hunting and gathering to agricultural production marked a key moment in human history. The events surrounding the spread of domesticated crops from Asia, the spread of agriculture, Southwest Asia across the diverse landscapes and societies of early Europe, from the arid Mediterranean to the temperate shores of Northwest Europe, involved a complex set of interconnected changes in lifestyle, but in virtually all cases ended with land coming under the plough. Archaeologists don't fully understand the nature of the transition in the disparate regions, but if we did, it may well offer clues to the reasons why farming based on the cultivation of a handful of plant species became the dominant way of life across Europe and the rest of the world. Possible explanations for the delays in agricultural spread could be a slow uptake of agriculture by existing human populations due to the relative success of the hunter-gatherer lifestyle, or a reflection of the time taken for crops to adapt to alien climatic conditions. The spread of agriculture in Europe are largely based on wood charcoal collected from sites classified as Neolithic or the period associated with early farming, on the basis of artifacts such as pottery or other cultural evidence found at the sites rather than on the products of agriculture itself. These are poor measures of agricultural spread. The earliest appearance of cereals at sites throughout Europe provides a better marker to chart agricultural progression. In some respects, these results support previous work indicating that cereal cultivation arrived in Greece from the Fertile Crescent region of Southwest Asia and then spread rapidly into the Balkans by around 7,950 BP. Subsequent movement across Europe followed two major routes. Advances in radiocarbon dating and Though it has been suggested that here too agricultural spread was an interrupted process, there is no evidence for this. The second route through the interior of Europe is hotly contested, with some researchers seeing the spread of agriculture slowing when it reached central Hungary before again moving rapidly through the Danube and Rhine valleys, while others assert a more uniform rate of spread from the Balkans to northwest Europe. Origin and dispersal of Indian agriculture. Agriculture was well established throughout most of the subcontinent by 6000 to 5000 BP. Evidence of the presence of wheat and some legumes in the 6th millennium BC have been found in the Indus Valley. Oranges were cultivated in the same millennium. The crops grown in the valley around 4000 BC were typically wheat, peas, sesame seed, barley, dates, and mangoes. By 3500 BC, cotton growing and cotton textiles were quite advanced in the valley. By 3000 BC, farming of rice had started. Other monsoon crops of importance of the time was cane sugar. By 2500 BC, rice was an important component of the staple diet in Mohenjo-daro near the Arabian Sea. The Indus Plain had rich alluvial deposits which came down the Indus River in annual floods. This helped sustain farming that formed basis of the Indus Valley civilization at Harappa. The people built dams and drainage systems for the crops. South India, center of the later distinctive Tamil culture, constituted a second, initially independent agricultural region. Crops were being raised there during the first half of the 4th millennium BP. Two varieties of pulses, legumes, and finger millet, also called ragi, were cultivated there. To the north and the west of the Deccan Plateau lay a third intermediate area. There, at Lothal and Rangpur, has been found the earliest South Asian evidence of rice cultivation in the later Harappan period. Subsequently, wheat, cotton, flax, and lentils spread into the region from the Indus Valley, and pulses and millets from the south. In all three regions, the basic cropping pattern of the 4th millennium BP, except the pattern for rice, continued into the 21st century. By 2000 BC, tea, bananas, and apples were being cultivated in India. There was coconut trade with East Africa in 200 BC. By 500 AD, eggplants were being cultivated. A fourth South Asian agricultural region, the Ganges River Valley, became increasingly developed after about 3000 BP. Although it is clear that some of these changes arose from the contact with Indo-European speaking people known as Aryans, notions of a devastating Aryan invasion are mistaken and in the past tended to obscure objective research on the region's history. Apparently, rice played an important role in the growth of population and the founding of new settlements. These had spread eastward to the Ganges Delta by about 2600 BP. In the later Vedic texts, c. 3000 to 2500 BP, there are repeated references to agricultural technology and practices including iron implements, the cultivation of a wide range of cereals, vegetables and fruits, the use of meat and milk products, and animal husbandry. Farmers plowed the soil several times, broadcast seeds, and used a certain sequence of cropping and fallowing. Cow dung provided fertilizer, and irrigation was practiced where necessary. Rice predominated in the eastern states, on the southwest coast, and in Kashmir. Aside from its original home in Gujarat, it had spread also to the Punjab and Sindh with the aid of irrigation. Wheat grew throughout its natural region in north and central India. Millets were cultivated in the wheat areas and in the drier areas of Gujarat and Khandesh as well. cultivation of tobacco, introduced by the Portuguese, spread rapidly. The Malabar coast was a home of spices, especially black pepper, that had stimulated the first European adventures in the East.
Agricultural origins cannot at present be conclusively proven to have begun close to 10,000 years ago, when additional evidence for agriculture extends further back in prehistory. What can be unequivocally stated is that agriculture had already emerged several times in numerous parts of the world in the last 12,000 to 20,000 years, and possibly as early as 50,000 years ago, with the last 6,000 years producing the most evidence for this cultural phenomenon. Genetic manipulation of plants, particularly cereal grains, occurred at some point in prehistory by people who already had the knowledge to do so. Evidence points to the Fertile Crescent of the Middle East as the site of the earliest planned sowing and harvesting of plants that had previously been gathered in the wild. Independent development of agriculture occurred in northern and southern China, Africa's Sahel, New Guinea, and several regions of the Americas. The dispersal of farming was clearly not a straightforward process. The transition to farming must be seen as a complex process resulting from several forces operating simultaneously at different chronological and spatial scales of resolution. This is reflected in all the literature, not just archaeological but linguistic and genetic as well.